Hello everyone. Today in this video, I will tell you the derivative of a function in parametric form. Derivative of a function in parametric form. First, let's understand what is parametric form. There are the cases when rather than defining a function explicitly or implicitly, we define it using a third variable. This representation, when a function yx is represented via a third variable, which is known as the parameter, is a parametric form. For example, if we have x equals at square and y equals 2at, these are two equations. We can see here x is expressed in terms of t and y is also expressed in terms of t. That is, x and y are expressed in terms of a third variable, that is in terms of t. So these are the parametric equation of which function we have to find out. Let's find out. These are the parametric equation of which curve. We have x equals at square, say this is equation number 1, and y equals 2at, this is equation number 2. From equation number 2, find out t. T would be y upon 2a. Substitute this value in equation number 1. Substituting y upon 2a equals t in equation number 1. We will get what we will get. Let's check. X equals a t square, that is y upon 2a whole square. That is x equals y square upon 4a. That is y square equals 4ax. So what is this? This is the equation of parabola. So x equals at square and y equals 2at are the parametric form of equation of parabola. Similarly, let's take one more example. If we have x equals a cos theta and y equals a sin theta. Here also we can see x and y are expressed in terms of a third variable, that is theta. So these are the parametric form. Of which curve we have to find out. Let's check. This is equation number 1. This is equation number 2. Squaring and adding these two equations. Squaring and adding equations 1 and 2, we get squaring, that is x square, plus adding a square cos square theta plus a square sin square theta, that is a square cos square theta plus sin square theta, and we know that its value is 1. Simply you will get x square plus y square equals a square. And what is this? This is the equation of a circle. Equation of a circle, and having center or 0 0, that is origin, and radius a. And these are the parametric form of equation of a circle. So I think it's clear what is the parametric form of a curve. Now, how to differentiate? How to differentiate the curve if the derivative of functions expressed in parametric form? These are the steps. Number 1, first of all, we write the given function x and y in terms of parameter t. For example, we have x equals at square and y equals 2at. This is your first step. In second step, find out dy over dt and dx over dt. So from here you can find out differentiating both sides with respect to t, variable t. Dx over dt, age constant, and differentiation of t square will be 2t. Now dy over dt, dy over dt, 2a is constant and derivative of t will be 1. So we have calculated dx over dt and dy over dt. Now using the formula for solving functions in parametric form, what we will get, dy over dx. dy over dx equals dy over dt, that is 2a, upon dx over dt, that is 2at, 2a upon 2at, that is 1 upon t. So dy over dx equals 1 upon t. This is our final answer. Lastly, substitute these values and simplifying, we will obtain the result. This is our final. Similarly, we can find out if we have, it is given to us x equals a cos theta and y equals a sin theta. Here in this case, what we will do, we will find out dx over d theta. We will find out dx over d theta. That is minus a sin theta, and dy over d theta, that is a cos theta. Means it is not necessary that in all the cases we will have parameter t. We may have different parameter. Here we have the parameter theta. So we will differentiate with respect to theta. Now find out dy over dx. It would be dy over d theta upon dx over d theta. That is a cos theta upon minus a sin theta. That is minus cot theta. So we conclude that dy over dx will be minus cot theta. Now let's take one more example. Find out dy over dx when x equals t cube minus t and y equals 4 minus t at t equals 0. The first step would be, we will find out dx over dt. It will be 3t square, because t cube, differentiation of t cube will be 3t square minus differentiation of t will be 1. Now find out dy over dt. It is constant, 4 is constant, its differentiation will be 0 and derivative of t would be minus 1 only. Now find out dy over dx. It will be dy over dt upon dx over dt. Dy over dt is minus 1 or dx over dt is 3t square minus 1. But we have to find out dy over dx at t equals 0. Means here substitute t equals 0, that is minus 1 upon minus 1, that is simply 1. So dy over dx at t equals 0 is 1. Next example. It is given to us x equals a 20 minus sine 2 theta and y equals a 1 minus cos 2 theta. Find dy over dx when theta equals pi by 3. So here also we will find out dx over d theta, that is a. Age constant, it will remain as it is. Derivative of 20 will be 0 minus derivative of sine 2 theta. This is the applying chain rule. Sine theta, it is theta in my mind. Sine theta is cos theta and derivative of theta again will be 2. Similarly, from here dy over d theta, a as it is, derivative of 1 will be 0 minus cos 2 theta. Derivative of cos theta is minus sine theta. So minus minus will become plus. sine 2 theta and derivative of 2 theta will be 2 again. Find out dy over dx. It would be dy over d theta upon dx over d theta. That is 2a sine 2 theta upon minus 2a cos 2 theta. That is minus tan 2 theta. 2a sine 2 theta upon minus 2a cos 2 theta. 2a cancel, minus tan 2 theta. But we have to find out dy over dx at theta equals pi by 3. It will become minus tan 2 pi by 3. And we know according to trigonometry, find out the value. Minus tan 2 pi by 3, we can write pi minus pi by 3. 2 pi by 3, if I simplify this pi minus pi by 3, I will get 2 pi by 3. And tan 180 minus theta. Tan 180 minus theta, we are in this quadrant, it will be minus tan theta, that is minus minus plus tan pi by 3. And tan 60 degree, we know it is pi by 3 means tan 60 degree. Tan 60 degree, we know it is root 3. So dy over dx at t equals, not t, it is theta. At theta equals pi by 3 is square root of 3. There are the cases where we can simplify first and then differentiate. For example, we have x equals square root of a raised to the power sine inverse t and y equals square root of a raised to the power cos inverse t. Show that dy over dx is minus y upon x. The first way is we will find out dx over dt, dy over dt, and then we will find out dy over dx equals dy over dt upon dx over dt. This is the first method. But other way, we can find out, say this is equation number 1 and this is equation number 2. Multiplying equation number 1 and 2. Multiplying equations 1 and 2, we get xy equals, left side, x into y, a raised to the power sine inverse t into a raised to the power cos inverse t square root. On multiplying, we will get it a raised to the power sine inverse t into a raised to the power cos inverse t square root. We can write it as, in multiplication, if base is same, we know the rule of exponential. Sine inverse t plus cos inverse t. And we also know that sine inverse t plus cos inverse t, its value, inverse trigonometric function, we know that it is pi by 2. We know that sine inverse t plus cos inverse t is pi by 2. Substituting this value. Now we have the simplified form. Say this is equation number 3. Now differentiating it. What we have done, first we have simplified it. We have eliminated t variable. Now we can find out dy over dx. Differentiating both sides with respect to x. Differentiating both sides with respect to equation number 3. Differentiating equation 3 with respect to x. You will get derivative of x will be 1, y as it is, plus derivative of y will be dy over dx and x as it is. And because it is constant, its derivative will be 0. From here, you will get dy over dx equals minus y upon x. So, I hope it is clear how to find out derivative of parametric form. That's all in this video. Thank you for watching.